So let's say you have two curves. You have that, you have that, and you know what the point is here, x, y, and this curve is f of x, this curve is g of x, and you want to find the area between the curves. So basically what you do is you find the area of this curve, the area underneath this curve, then the area underneath this curve, and then subtract the bigger area from the smaller area. And how that's going to look is the integral from a to b of f of x dx minus the integral from a to b of g of x dx.
Another way you can look at this is, instead of finding the entire area under the curve here and the entire area under the curve here, you can just take this f of x height at this point and the g of x height at this point and set up your rectangles like you do for Riemann sum. And then to find this height, you take f of x at that point, subtract it from g of x at that point, and then as this width here, this d of x, approaches 0, you'll end up getting the entire area under here if you take the integral. So that would look like this. So you have the integral from b to a, f of x minus g of x dx.
So the real world application, or one of them, is if you have two curves and you have the area between the two curves and you're trying to rotate it around an axis. So if, let's say you're rotating around the y-axis, you'll have this, but you'll also have that, kind of. And when you rotate it around and it comes 360 degrees all around, you'll have a bowl. And then you could figure out, using the area between the curves, the area of that bowl. Or, instead of rotating it around where they share a common point, let's say you're rotating it around this axis over here, and then you have something like that, and instead of making a bowl, you're making a washer shape or a donut shape all the way around, and then you can find the area of that washer.
So here we have the graph of f of x and of g of x, and we're trying to find the area in between the two. So here we have both functions, and we need to find the points where they intersect, which should be right here and right here. To do that, you need to set both functions equal to each other. So here you'd have x squared is equal to the square root of x. You would square both sides of the equation. So you have x to the fourth is equal to x. Set that equal to 0, and then you can factor out an x. You have x to the third minus 1, and then since you have an x here, that x is equal to 0, and then if you solve that, you would get x is equal to 1. So these 2 points are where the two functions intersect. So on the graph, that's 0, 0 here, and then this will be 1 here. So we need to take or set up our integral here. We have the integral going from 0 to 1 of our top function, which is g of x. It lies above f of x here. So we take g of x, which is the square root of x. We subtract f of x from that, which is x squared. And then d of x. So then now we just integrate that. And the square root of x is the same as x to the 1/2. So if we integrate that, we get x to the 3/2 times 2/3, and then we subtract x to the third over 3 from 0 to 1, and then we go ahead and plug these values in. If we plug 1 into here, we get 2/3. If we plug 1 into here, we get 1/3. And then subtract, if we had 0 plugged into both these, we just get 0, so we subtract 0. And then 2/3 minus 1/3 is equal to 1/3. So you know the area between the curves is equal to 1/3. That's this area here.